Hello again, and welcome back to another Wise and Unreal tutorial, where today we're going to be looking at adding first-person footsteps to the first-person demo little game, well not really a game, it's more like a single level, that Unreal provides for you from the get-go. Now if you're completely new to Wise or Unreal, I'd recommend you check out the video I made before this, talking about how we integrate Wise into Unreal, because there was kind of some key concepts there that will bleed into kind of this video and all the other videos we do looking at these two pieces of software. Just things like, you know, getting the sound bank files to work and setting up the program, stuff like that. So I'd recommend you check that video out first before watching this. Once you have, come straight back and we'll look at using the blueprint system to start playing some sounds. Okay, we're jumping straight into this lesson today. So I'm going to start by looking at the Wise project I've set up and just running you through how I've imported some footstep sounds and how I've kind of set them up in Wise to be played back for a first-person character. So the first thing you want to do is just make sure you're in the designer layout, which is the one you're looking at here. The layouts in Wise, they're very similar. They're all grey, and it's kind of hard to lose track of which one you're on from time to time. So I like to go up to layouts here, just make sure I'm on the designer one before I start doing anything. Once you are, the first thing you're going to want to do is import some audio files into Wise to use. Now for our first person character that we've got in Unreal, we're going to want to import a few footstep sounds. We don't want just one file, we want a few that we're going to randomly play as the character starts to move. So the way that we're going to randomly play them is by using, I believe it's called a random container in Wise. I can't remember the name, I had to quickly check. To do that, to create a random container, in the audio tab here under the Project Explorer, which unless you've changed it, should be in the top left of your screen, you want to click on the default work unit and you want to select create new random container like that. It creates a new one. Give it a name, I've called mine Footsteps. And then once you've done that, I'm just going to quickly delete this because I've already got one. Once you've done that, we can import some audio into it. So what you'll then want to do is right-click on your new random container, go to Import Audio Files, and from here you can either add the files individually, or if you've got them all saved in one folder, you can select the folder itself and import it that way. Either way, once you've selected all the files that you want to import, just click OK and then click Import. On the audio file importer, you should be good to go. And then once you open up the random container, you should have a big list of all the sound effects. I think these are just the objects, are they called? Let's quickly have a look before I start getting my terminology wrong. Sound SFX, so we'll call them sound effects objects. So you should have multiple sound effects objects that are nested under your random container as child objects, essentially, and you can tell them because they've got this speaker symbol that basically just means it just contains an audio file, essentially. So we should have, I had 9 audio files, so I should have 9 sound effects objects nested in my random container, which I do. And then to check you've picked the right files, select each one. We don't have to, but you can select them, and you can just come down to the transport bit at the bottom here and just hit play, just to make sure they're playing and working. So before we move on, you might want to do a little bit of tweaking to the random container so it feels a little bit more random and believable that these are, you know, footsteps of someone walking around. You can kind of tweak this as much as you want. I kept it nice and simple. All I did is I just gave it a bit of pitch randomization. And the way you do that is you come over to, well, yeah, make sure you've got footsteps or your random container selected. Then come over to pitch in the, what's the name of this window called? I don't know, but this main window here. Come over to this main window here. Oh, general settings. Here you go. And click on this little symbol that is really hard to see and kind of looks like the Pepsi symbol, but without the blue and the red. It's just orange. Click on that, and you're going to want to set a minimum and maximum offset. Basically, this is like a range from which your pitched audio can be played at. I believe this is in cents, if you're familiar with cents, pitching audio. Not too sure, but either way, just tweak the values until you find a range that you quite like. What you can also do is adjust the play type. I can't remember what the default is, but I've set mine to shuffle. And what's handy is you also get this property help window, so it'll actually tell you what these do. So I set mine to shuffle, and I've set the avoid repeating last option to 1. So this just means that it will prevent, if it plays a footstep the next one won't be the same one as the one just played. You know, you don't want to hear two footsteps at once. That's all that does. And that was pretty much it for the kind of design of my random container. So once you've done that, tweak some settings. You can also add some volume randomization if you want. Again, just hitting the little Pepsi symbol or other. You can tweak whatever you want. But anyway, once you've done it, click on your random container, go down to the transport control, and play it a couple of times. Sounding good to me, so let's move on. Once you've finished making your edits inside the Project Explorer and the default work unit, you should notice, it's hard to see, but a little kind of star symbol has appeared next to where it says default work unit. That means that the updates you've made haven't been saved. And if they're not saved, they're not going to carry over into Unreal and you're not going to hear your audio. So once you've finished making your updates, click on that and hit Control S to save, or if you're on Mac, I'm assuming it's Command S. Next thing we want to do is create an event, and this event is not only going to house our random. Next thing we want to do is create an event, and this event is not only going to house our random container, but it's also going to tell it to play. So let's move over to the Events tab, and we want to create a new event. So you do the same thing, you click on the default work unit, and this time you click this little symbol up here, Create New Event. And I've already done it and called mine Footsteps, so I'm going to click on that. The next thing you're going to want to do is assign the random container to this event. So I'm going to quickly delete this because I've already done it, but I'll re-demonstrate it for you. With the event editor window open, go back to your audio tab, find whatever it is you want to play, so our random container, and just drag it over like that. Then you want to also make sure that the type is set to play. We don't want it to stop or pause or break and do anything else. When we call this event in Unreal, we want to make sure that this random container plays. The final thing you want to do in Wwise is move over to the Sound Bank window, which is up here in the top left. You go Layouts and you go Sound Bank. So as you'll know from the last video, Sound Bank is basically a file that's going to hold all this information we've set up in Wwise that Unreal can read and play. So I'm not going to show you how to create a new sound bank. That was in the last video, so check that out. But what I am going to do is I'm going to make sure that my event Footsteps is assigned to this bank master, which it is, so that's good to know. Then I'm going to click Generate All. So this is going to generate my sound bank file with my new event assigned to it, which will mean Unreal can play that event. And that's it for Wwise. So I'm going to hit Control S. And we're going to move on over to Unreal. Okay, so in Unreal, there's a few things you're going to want to set up that, again, were in the last video where we looked at Unreal and Wwise. So I'm not going to go into them in too much detail, but I'll quickly list them off for you. You'll want to create an audio kinetic event, which is going to house the event you created. And you're going to want to make sure that's named exactly the same thing as the event you created in Wwise was. So going into Unreal, mine's here, Footsteps. So I've created that. And if you double click it, you can also see that I've assigned it to my master bank. Now again, if you haven't already, you'll need to create, just like you've created an audio kinetic event in Unreal, you'll want to create an audio kinetic bank. This does the same thing, but instead of housing a single event, it's going to house that bank file I talked about earlier. So once you've created one, double click on that, just make sure it's on auto load. And again, not going to show you how to do them. Check the other video to learn how to do them. What I am going to do is come up to Build, and because I've made edits to my soundbank file, I'm just going to click Generate Banks to make sure they've carried over. So I'm going to hit Available Banks Master, which is the one I've called and created. The platform I'm building, I'm not actually making a game, but this little project is kind of being built for Windows. So I'm going to click Windows and click Generate. There you go, and that awkward little high-pitched sound means that the bank has been generated and we're all good to go. Now, if you want, you can quickly test that all of this has gone well for you and that your audio is imported into Unreal successfully by simply finding that audio kinetic event that you created and just dragging it into your level somewhere. Then in this window here, the details window, which is going to show you all the information about the actor object, which is something we need to talk about at some point. It's going to give you all the details about what it's doing and kind of how it works in this sort of scene or level. So once you've dragged it into your scene, scroll down and we want to find AK ambient sound. Yes, I believe it's this. And then you're going to want to hit auto post, which is basically going to tell the event to play as soon as the game starts running. So once you've done that, let's hit play and see if we hear a footstep. There we go, we did, brilliant. So now we know that the audio is imported into Unreal, sorry, and we're good to go setting it up to attach it to our player. What I'm first going to do is quickly delete that actor object I've created. So find it in your world outliner and go edit and then delete. There we go, all gone. Okay, so the footsteps event, we know that we want to kind of attach to the main player. So what we're going to want to do is find the blueprint in this project, I suppose, that is doing everything associated with the first person character. Now in Unity, what we're used to is creating a game object, whether that be a player or a box or just something, then assigning scripts to that object, and then writing code in that scripts to get things to work and do stuff, right? But in Unreal, the way I understand it is that you kind of do things the other way around. Instead, you create a blueprint, which is where you assign all your functionality into. It's a code, essentially. It's just visual. You create a blueprint, and then you assign objects to that blueprint for it to interact with. So in this case, we want to find the blueprint that our first-person character here, if I zoom out, you can see it a bit better, has been assigned to. Now, in the first-person demo scene, project, whatever, that Unreal provides for us, you'll find it inside the first-person blueprint folder in your content browser. So click on that, go to Blueprints, and then go First-Person Character, and double-click on that to open up the blueprint. Okay, once you've opened your blueprint, you should see something like this. What we want to do is move from the viewport tab to the event graph tab, because this is kind of where the actual nodes and the programming are nestled and kind of live. Yours should look something like this, but as you can see, I've added some new nodes and some new features, and this is what's going to play our audio kinetic event that contains our footsteps. So what I'm going to do is I'm going to explain how this works. I've broken it up into 4 stages, and we're going to move along each stage and explain their role and kind of how they work together, essentially. So let's start with the very first stage. Okay, so step 1 of this blueprint does 2 things. The first thing it does is it tells this whole blueprint chain to kind of run and do whatever it is that we're telling it to do. And it does that for every frame of the game that is shown, which roughly happens, depending on the game, about, let's say, 60 times a second. So 60 times a second, this node here, which I'll talk about a bit more later, is going to tell the rest of the nodes to do stuff, essentially. The second thing it does is it creates a timer. What this timer is going to do is basically measure how long it's been since we played our last footstep. Because obviously we don't want to play our footsteps every frame. We want to leave a bit of a gap in time. So by creating this timer, we can measure how long it's been since we played our last footstep and say, okay, don't play a footstep again until it's been 4 seconds. I think I set mine to 4 seconds. So that's what this does here. It doesn't actually tell the event to wait just yet. It's just measuring how long it's been since we played our last footstep. Step 2 then checks for a couple of conditions before we move on and start playing our footstep. The first thing it does is it checks to see if the player is moving, and it does that by seeing if there's any input from the player, basically. Are they pressing W, A, S, or D on their keyboard? Which is what this bit here does. Not only that, it also uses that timer we just created and say, only do more stuff in this kind of chain of blueprints if the timer reaches 0.2 seconds or 22 seconds. If both of those conditions are true, if the player's moving and it's been 0.22 seconds since we've heard a footstep, then we move on to step 3. Step 3 then checks to see if the player is on the ground. Obviously, if the player's in the air, we don't want to play a footstep. So if they're on the ground, then we will continue on with the rest of our blueprint. Finally, when we get to step 4, we then play a footstep for the player to hear. And we also then reset the timer back to 0 so it can keep counting for the next footstep to play. We've also got this little optional chain up here, and all this is going to do is display whatever value our timer's at, or whatever seconds they're at, in the game on the left-hand side. You'll kind of see the numbers drop down the screen, just so we know how long it's been since the footstep last played. Okay, so that's how the blueprint works. Now it's time to talk about each individual node and kind of just not only the kind of specifics of how this works, but also the specifics of how blueprints work in general. Okay, so for any blueprint to work in Unreal, you need what's called an event. An event is going to run multiple nodes, like the rest of our nodes in this blueprint here, depending on something specific. Like I said, in our case, we want ours to run every frame. So the event we use is called event tick. And if you're familiar with Unity and C#, event tick is basically the update function. It's going to shoot a signal or run 60 times a second, or every frame a second. Every frame, you know what I mean. Now, if we take a look at event tick, it's got two little dots and then two lines coming from those dots. Now, the first one is the execute dot. I don't know what the name, I'm calling them dots. But the execute dot kind of acts like an order. It's like an instruction list. It basically, everything along the white line is going to happen after each other, if that makes sense. It's also going to tell those nodes to do their thing. So you start at the beginning of the line, and then you work your way over between each node that it connects, and then it kind of fires it and triggers it to act. So in our case, we start at the event, then we move on to this set variable timer. Again, I need to learn the terminology. What is this called? It's just setting a whatever, it doesn't matter. It moves on to this bit, then it moves on to the branch node, then it moves on to the line trace by channel node, and so on. And they're all done in this specific order. There's no data actually being sent. There's no information being sent in between these via this line. It's literally just telling them to do stuff in a specific order. Okay, underneath that, we've also got a green dot. Now, in Unreal, what's quite nice is all these lines and dots and stuff, they're color-coded, which means we can quickly identify what the lines are actually doing. So just like white was an order of execution, an instruction list, essentially, what green does is it actually passes data along it. It's actually passing float data, which is numerical values that can have decimal points in. Now, what event tick does, as well as fire off and start our signal every frame, is it also will measure the time, how long it's been, since the last frame fired. And that's called delta seconds, or delta time, which is usually a very small value. It's usually like 0.08 or something like that, because obviously frames are happening 60 times a second and they're very quick. So what we want to do is every frame is take the value, measure how long it's been since the last one, and keep adding them together. And that's how we create our timer, by adding all these delta seconds together. So the way you find the event tick event, I think for most blueprints it starts with it automatically, but if yours isn't there, you right click and just type event tick, and it should be here. Add event. It's this little white arrow in a diamond, and event tick. You click on that, and I've already got it, so I didn't create one. But boom, that's how you will create one in Blueprints. Cool, so what we want to do, like I said, is take those delta seconds, add them together, and then store them somewhere so that we can then check that storage system to see how long it's been since we last played our footstep. And what we need to do to store them is create a variable. And we create a variable of the same data type, which, as I said, the data type, because it's green, was float. So to create a variable, what you're going to want to do is come over to the variables tab on the left and click add new variable, the little plus sign. Then give it a name. So mine was called timer. I'm just going to call this one timer2. And you've got a variable. But what you need to do is make sure you set it to the same type as whatever it is you want to, whatever information you're trying to store inside it. So like I said, float is what we're after. So on the right here, we want to change the variable type from Boolean, which is the default, to float, which is the green one. What you can then also do is set a default value for the variable to start at. First, you need to just quickly hit compile on your blueprint, and then you'll get this little option here, default value. And for this, just make sure it's set to 0 to start with. Once you've created your variable and assigned it the right data type, you simply come back over to the variables tab, drag it over to your blueprint, let go, and then you can choose whether or not you want to use it to set a new value to the timer, or if you just want to retrieve whatever value is currently in it. For example, 0 is the current value. For this, the first thing I did is click not set timer. My mistake. You want to drag it over and click get timer. And then as you can see, we've got this little node here that we can pull out the value of our timer from. Now we do want to set the value of this timer, but first, the reason why we want to get it is because we want to add whatever the delta second is that we're pulling from the last frame. We want to add that to whatever the timer is currently at the moment. So that's where this next node comes in, which is the kind of addition node. The way you get that up is you right click, just click or type float addition, I think. Oh, actually, you don't even need to do that. Just type in float, and then you look for float plus float. Here you go. So addition A plus B. Click on that, and it brings you up a little addition node. So nice and simple. All the information being put into the left side of the node is what you're adding together, and then information coming from the right is the result, essentially. So we drag a line from delta seconds into the first pin of the node. So we're adding the delta seconds, how long it's been since our last frame, to whatever value our timer is currently at, which is 0. And then the result we get, we want to enter it into this new node. And this is the set node, so this is the one I accidentally pulled up with timer 2. So I'll drag this back in, and this is what you'll want to do for your timer. Drag your timer variable back into your blueprint. This time select set, and it will allow you to set this new value you've created by adding the delta seconds with its old value. So then you drag your pin into the left side again. Oh, sorry, not the... as you can see, it gave me a little red naughty sign there. And that's because I was dragging the green node, the information, the value we were getting, into the execute node, which, like I said, is just an order of execution. It doesn't take information. So make sure you drag it into the green part there, and that's going to assign the new value, the result of this addition node, to your variable. But I've already got one. I don't need that. I'm going to delete that because I've already done it. And now you've created a little system where after every frame, we're going to be adding some certain amount of time to our timer. So it's just going to count in seconds how long it's been, basically. Cool. So once you've set up step 1, and after the event tick event, you've told your variable to set a new value for it, essentially, you'll want to move over to step 2. And the first node you'll want to create is a branch node. Now, a branch node is basically an if statement if you're at all familiar with Unity and C#. And what an if statement does is it basically says, okay, check a condition. If something is happening, something specific, or something isn't happening, then we want to do something else based on that, right? So to create a branch node, right-click and just type in branch, and it's this one here with the white arrows that kind of go off of each other. Click on that, you've got yourself a branch node. You'll also then want to drag the execution line into the branch node, telling it to activate, basically, once we've set our timer value. So the way the branch node works is that, like I said, you tell it to activate by giving it the execution line. And then you need to give it a condition. What's it going to check for? It needs to measure something, and then depending on the result of that thing it's measured, it will do one of two things. Now notice that condition is a red line or a red kind of pin. That means it needs information of the Boolean data type. Now Boolean data type basically it just means it contains two values, true or false. That's it. So it's quite a nice and easy one to make. So what I'm doing here is I'm saying, okay, if the Boolean value you receive, Mr. Branch Node, is true, then I want you to continue and do something else. Move that execution line over to whatever's the next thing I've put in this line. If it's false, I haven't told it to do anything, but you could if you wanted to. You could maybe use it to, I don't know, display something in the game and say why it was false. Use your imagination. But we're only really interested if it returns true. Now let's take a look at the things I'm measuring to basically determine whether or not I'm going to get that true value. Remember, I said there's two things we need to measure in step 2. It's whether or not the player is moving or pressing W, A, S, or D on their keyboard, and whether or not the timer has exceeded a certain amount. Now, because I want my branch node to check for two conditions, basically, I need to use this node here, the AND node, and this basically allows you to feed two different Boolean values. It could be a variable, but two values, two true or falses into it, and then if both are true, it will then continue on and feed that into branch. Well, it doesn't necessarily have to be both true. If either one of these are false, then it will basically send the branch the false value, and then false will kind of move on and do whatever. But that's the key thing about the AND. Check both of the Boolean values you send into it need to be true for it to, fire off the true execution pin on the branch node. If you need to check for more conditions as well, it gives you this handy little add pin option. So you click that, and it creates a extra little pin for you to add another value into. And again, that also needs to be true. All three of these will now need to be true. But I only want to check for two things, so I'm going to right click and click remove pin. And we'll start with the bottom one, because that's the nice and easy one first. We take the timer. Again, we want to measure the timer, so we come over to our variables and drag it over, We click get because we want the value of it. We get our timer value, and we want to basically check if it's greater than a certain value, if it's been so long since, we've played a footstep. So we want to use this node here. So to get that up, you right click and you type, I think you just type float again, and you just look for the greater than symbol. So it's not that one, it's this one here. If float is greater than float, click on that and boom, you've got yourself a greater than node. So like I said, it's going to check if the value entered into the first pin is greater than the value in the bottom pin. So I've said if the timer value is greater than 0.22 seconds, which I manually entered, and you can change that to whatever you want, then I want you to send the Boolean value as true. So that's quite a nice easy one to understand. So that's the first node or first value that our AND node is measuring. Then or first condition rather. Then we've got Then we've got a second condition we want to check for, and this is the one that checks to see if the player is pressing a button. So we start over here, and these are two more event nodes. So event nodes, as we know, they execute other nodes to run and do stuff with, basically. But that's not exactly what we're using these for. You can see they have the white pin, but we're not doing anything with them. Instead, we want to take a value that they can also measure, and that value is basically a 1 or a 0. Now we'll start with this top one, input axis move right. And the way you get that, just right click, type in input axis, and let's take a look for move right. Scroll up a bit maybe, all the way to the top. Here we go, so here's our events. So move right is the one we want. So move right, as well as executing stuff, so you could say do something if move right is pressed. It will give us a value. And like I said, that value will either be 0, 1, or -1. If it's 1, that means that the button has been pressed, whatever's assigned to the right button, which in our case is D, that's the default for Unreal. If it's 0, that means nothing's been pressed, and if it's -1, A is being pressed. Essentially, move left is what it's being told to do. And to get that value, you come down to the axis value pin here. Again, it's green, meaning it's float data, so it's numerical values with decimal places, and then you drag that over to this node here. The reason why it's a float value, by the way, is because I believe you can have bits in between. I think it can measure, I might be wrong, but over a certain time it might move from 1 to 0 and all the decimal places in between. I might be wrong, but I think that's why it's a float. Anyway, the node that we put that into is basically check to seeing if it's not a certain value, or if something, it does not equal the other thing. The first thing we're checking for, obviously, is the input axis. Then the second thing we're checking for is the value 0. So basically what we're saying is the axis value anything other than 0? Because if it's anything other than 0, it must be being pressed. Either A is being pressed, which means we're moving left, or D is being pressed, which means we're moving right. So that's what this is checking, and you can tell that's what it's... can I zoom in at all? Oh, I can't zoom anymore. You can't really see it. But there's a little exclamation mark followed by an equal sign, and that basically means is the first condition not the same as the second. So to get that up, right click, it's another float thing, so type float, and look for, I don't know where I'm going to find this one. Maybe if I type equal instead? Not equal, that looks right, doesn't it? Gameplay tags, grid, input, boolean, not equal. I think it's this one, so it's under math, boolean, not equal. Yes, there we go. Oh no, that's taken no, never mind, that's not it. Right click, float, not. There we go. Okay, so not boolean, sorry. Well, I mean, you can check if two booleans aren't the same, but we're checking float. So under math, float, you want not equal. So click on that. And you can tell this is the right one because it's got two green nodes followed by I nearly said blue then, a red node. But anyway, I'm going to delete that. So yeah, that's pretty much that. And what we're doing is we're doing that twice. We're doing that for the input axis move right event. We're also doing it for the input axis move forward. And it works exact same way, but this time forward is measuring to see if the player presses W to move forward or S to move back. 1 being W and -1 being S. And 0 again meaning neither. So again, we want to check to see if input axis move forward is anything other than 0. If it doesn't equal 0, then we want to send a true value over to our branch node. But as you can see, we're not sending it straight into the branch node. What we're doing is sending it into this OR node. Now, OR works exactly the same as AND, or near enough exactly the same. The difference is where AND had to, basically with AND, both of these had to be true for it to send the true value into branch, but where with OR, either one of them can be true for it to send true. For example, if this is true and if A is true and B is false, meaning we're pressing S or D but not W or S, sorry, A and D, not W or S, then it will send true over to AND, which can send true over to branch. But with AND, if A was true and B was false, if the timer hadn't reached 0.22 seconds, then it would send false over to the branch and we can't continue our path. Okay, so that's the difference between the two. So to sum up, if input axis move right is not equaling 0, or if input axis move forward doesn't equal 0, and the timer is greater than 0.22 seconds, then send the true value to branch and then continue on with our node or our blueprint to execute more stuff to happen. And then with that, we can move on to step 3. Now, as we know, step 3 is designed to check to see if the player is on the ground. The way we do that is with this node here, line trace by channel. The way you find that is right click, line trace by channel, and it's this one here under collision. Okay, now this one, as you can see, there's a lot of information we can feed it, but try not to let that confuse you too much. We're just going to focus on the stuff that we need to worry about in this, which is only like 2 or 3 things. So obviously the white line we know executes it. So once branch equals true, then we're going to fire our line cast. But I should tell you what a line cast is. A line cast is basically the same as a ray cast, if you're at all familiar with them. All it does is it fires an invisible line in our game world from a certain point, which I'm going to talk about in a bit. Fires that line, and then depending on what that line hits, we can pull information from it. And we can give it a certain distance to travel, a certain direction to travel as well, etc. So it's a good way to find things in our world based on a specific position. What we want to do is we want to fire it straight down from the player character and see if it, and send it a certain distance. So we'll say, don't go too far, don't go infinitely far, but just travel a certain amount of distance, about the height of the player basically. And if that line hits the ground or just hits any object, then we know the player is on the ground and therefore we can play a footstep. Now the main 2 pieces of information line trace by channel needs is a position to start the line from and a direction essentially to send it in. So we want to send our line from the location of our player object. Now our player object, if I go back to viewport, is this here. And the majority of it is based around this capsule that you can kind of see here. So I'm going to kind of send it from the center of that and send it straight down. To do that, we need a reference to that capsule itself. As you can see, with this object that we're kind of interacting with, there's quite a few things. There's a camera, there's arms, there's 2 guns for some reason, even though there's only 1 gun in the game. But whatever, there's multiple components, so we need to specifically say we want to interact with the capsule. And the way we do that is we come over to components. Basically, we find the capsule, which is this one here at the top. It's like the parent of all the other kind of objects assigned to this blueprint. And we drag it in and we place it in our blueprint. Okay, so now we have a reference to that capsule object, that capsule component, represented by this little blue node here. Now, as you can see, this is a blue pin firing off a blue line, which is kind of represents references to specific things in blueprints. However, the line trace node is yellow. So we need to kind of, which by the way, yellow is taking in vector data. And vector data is basically the same as float data. It's numerical values with decimal places. But it's 3 of them specifically, 1 for each axis. So if it's a 3D game, you'll have 3, 1 for the X and the Y and the Z. And if it's 2D, you'll have 1 for the X and 1 for the Y. So it's kind of multiple numbers essentially. Anyway, we need to turn that blue into a yellow, and the way we do that is with this node here, get world location. So what get world location does is it takes a specific object that we tell it, a target, and then it finds where in, let's go back into Unreal quickly, close that. It finds where in this world, what coordinates it's at. And again, because we're firing this every frame, it's going to do this every frame. If I click on the actual object here, we can see where it starts. It starts its location at x minus 260, y minus 60, and z 266. So on the very first frame, let's go back to the blueprint. on the very first frame, that is the vector value it's going to find. So once we've done that, we simply drag the line into the start pin of the line trace. Cool, halfway done with the pins on the left side. Now we need a place to end the line. So we know it's going to start at the center of that capsule, but where's it going to end? Well, we do that with this end pin here. Now, as I said, what I want to do is send it straight down. So I want it to end basically at the bottom of the capsule. So what I did is I took that same location vector, and before I didn't send it straight into the end, because what that's going to do is basically go from the center to the center. The line is going to be basically nothing. So before I sent it straight to the end pin is... Oh, sorry, I didn't even mention how I get this. So the get weld location, I'll quickly show you. Just type in get weld location, and it is get weld location, capsule component. So the one we're after it would be this top one here, get weld location. Under utilities, under transformation. Anyway, back to what I was talking about. Yeah, we want to fire the line straight down. So we want to take the location that we're starting our line from, essentially, the same value, which is from this node here. And then we want to adjust the values. So what I've done using this one here, vector subtraction, is I've said I want you to subtract 100 from the z-axis. Just a heads up, by the way, in Unreal, and this annoys me a bit, let's go back. In Unreal, the z-axis is kind of top down, right? So if I move over to our player, the blue line here represents the z-axis. I'm so used to Unity having y be the kind of up-down scale, but whatever, that's what we're dealing with. So sending the line straight down, we want to minus the center location by 100. Well, 100 was a rough guess. You can adjust it if you want, but it seems to work. By minusing 100, we're getting that position, which is at... Let's move down a bit. I'm still getting used to the controls. There we go. Basically, at this point here, the bottom of the capsule, because that's about 100 in the z-axis from there to there. So to get the vector subtraction node, let's just type in vector subtract, and it's this one here, vector minus vector. So you click on that, and it creates the node for you. So instead of minusing two set values, I dragged the return value from get weld location into the first pin, which gave us the first value, and then said myself, as you can see here, minus 100 in the z-axis. And we feed that into the end pin, so we know we're going from the center of the capsule to the very bottom. Now this is optional, but what you can also do is draw the line in the game, which is probably not what you want to do. I'm sure it won't do it on its own, but you know, you don't want the player to see it, but don't worry, they won't. What it will do is draw the line in the editor for you to see, so you can see if the line is traveling in the correct direction and for the correct distance you want. So you just click on this drop down and click persistent. What's very important is that you also tick this little bit here, ignore self, tick that box. That's basically going to say, excuse me, that's basically going to say, if the line collides with itself, the object that we're starting with, ignore it. We're not interested in that. We're interested in any other object. Cool, so line trace by channel's got all the information it needs. Now we need to check to see whether or not it did in fact hit something below our player. If we, I can't zoom in, if we go over to the right side, we can see it outputs us a Boolean value represented by the red line. So it's giving us a true or false based on whether or not the line hit anything. So if it hits something, we can enter it into another branch node. And again, if that value it's sending is true, we can continue on with our blueprint via the true node in the branch. Sorry, the true pin in the branch node. And again, we need to hook up the line trace to the branch via the execution node to say, fire the line first and then check that value. Cool, let's finally move on to step 4. Nearly done now. Okay, so the first thing I did is I added this delay node, which you can get by right-clicking, type delay, and it's this one here, I believe. Flow control delay. Yep, it's that one there. Cool. So bring that up. Bring in your execution line into it and out again once you've done. What you could do is basically you could halt this line, this kind of execution line that we've been following along. You could halt it by a certain amount of time, delay it essentially. And the delay at the time I've chosen is 0.2 seconds. So if all of this is true, if the timer's gone over 0.2 seconds, if the player's pressed W, A, S, or D, and if that raycast, linecast, whatever, if that's hit the ground, then I want you to stop for 0.2 seconds before you continue. The reason why is simply, I'll show you this in a second, if I go back to the editor, is that when walking, there's kind of a bobble, right? And if if I told a footstep to play straight away, it was a little off with that animation. So by holding it for 0.2 seconds, all I'm doing is kind of waiting for the bubble to go like that. And then it looks like the player's kind of taken a step, which you then expect to hear a step from. So that's optional. You don't have to add that. In fact, you can even tweak it if you want. You might find that 0.2 seconds isn't exactly correct for you. It's up to you. But that's what I've done here. So wait 0.2 seconds before moving on. Then we want to basically play our audio kinetic event, our Wwise event. And that's what post event here does. So this is the first node that is specific to Wwise and comes with the integration package. So to get post event, right click, type post event, and it's under audio kinetic actor, and then click post event. And oh, sorry, that was post trigger, but you get the idea. Post event is what you want. Okay, so once you've attached the execution line into post event, first thing you want to do is say what event you want to play. So under AK event, you click this little drop down tab, select your event, and mine is footsteps, so I'm going to make sure that that is selected. Next, you want to give it a reference to an actor. Now, an actor is basically an object. Let's go back into Unreal again. So which one of these objects do we want to... go away. Which one of these objects in our project do we want to play this sound at, basically? Obviously, we want to play this sound at the position of the object that we're kind of interacting with via this blueprint. So the easiest way to do that, let's open the blueprint up again, is we use this node here, self. And if we read it, it says gets a reference to this instance of the blueprint. What it means by instance is, again, let me go back to the editor, is if I wanted to, I could drag another instance of this first person character in. So now we've got two, right? Two copies of that blueprint. So what it's doing, let's open up the blueprint again, is for each one, because we wrote self, it's saying play a footstep for whatever one of those instances, out of those two in my case, that I've attached this blueprint to, if that makes sense. So again, go back to the editor. Oh, let's close that. So for this one here, it's going to play a footstep at the location of this instance. And then for this one here, it's going to play another one at the location of this instance, depending on where they are in the world. Let me just quickly undo that because I don't want two of them. There we go. So the way you get self, right click, you literally just type self, and it's this one here under variables. Get a reference to self. Click on that, and you're good to go. Then once you've told which event you want to play, move the pin over to this extra node here, set occlusion refresh interval. And this is another node that Wwise provides us with. And to find that, just right click, set occlusion, this one here, interval. It was refresh interval, wasn't it? Yeah, so it's that one there. What this does is it's basically saying how often do you want to check to see if the sound is occluded from wherever the camera is in our scene. Now in our case this isn't it's not really that necessary because like I said, we're playing this sound basically underneath the camera. There's not really going to be anything blocking it, if at all. Maybe the arms, I don't know if that counts. But I want to make sure that this sound is never occluded because your feet are never occluded. There's nothing blocking your feet to be heard, and you don't want to apply that effect to it, do you? So I set the refresh interval to 0, so it's basically not going to happen. It's not going to do any occlusion. There might be a better way of turning occlusion off. Haven't found it yet. I'll let you know if I do. But again, just like with post event, you need to reference a specific object or a specific instance of an object. So we're just going to use we're just going to say reference this object again, the same one, self. So we're using the same node and we're dragging that into the actor pin of set occlusion refresh interval. Finally, the very last thing we do, now that everything else is done, we've checked all our conditions, we've checked it's safe to play the footstep sound, we've played it. Now what we want to do is reset that timer so they can start again and start counting on each frame to see when it's next due to play a footstep. So again, we find our timer variable, drag it in, click set timer, and we don't actually need to edit it because it already comes as 0. But the important thing is that this value here, that's the value we're setting it to, is 0. So you can just manually say set to 0 for that, and you're good to go. And then from here, you don't need to execute anything else. We're done. So we can just end the blueprint here, and we're good to go. So once you've done all of that, the last thing you want to do is hit compile and hit save, and you'll be good to go. Now, before we jump in and test this, I'll quickly explain also what this optional thing does here. So like I said, this just debugs basically. It displays the value of the timer. So to set this up, what you do is you drag in the timer variable here, and you say get whatever value it is, because we want to get its value and see it. Then you want to use this little conversion node here. And what this is going to do is convert the convert those numbers into string data represented by this pink line. String data is basically characters. It's letters and words and stuff. Now, whilst numbers aren't letters and words, they are, characters. So what it's going to basically do by turning it into string data is allow us to display the characters, that those numbers are, if that makes sense. And then we use this node here to actually print it, print string. And as it says, developer only, because it doesn't really do anything other than just show you, the developer, the value from whatever variable you're checking. So to get print string up, right click, type print string, and it's under string, as you can see there, print string. And then to get this little conversion node up that turns it from a float value to a string value, simply take your timer or whatever variable you're interacting with, drag it into the in-string pin, let go, and bang, it automatically does it for you. So you don't need to worry about that. So let's quickly delete that. There we go. And as a bonus, because I didn't know this for the longest time, right-click, type in comment, add, and you can see you get this little comment box, which is nice, helpful way of organizing all your nodes. That's, you don't have to use that, but I did because I quite like them. Before we jump into the scene to test this, what we can also do is hit play up here. This will run the game, but whilst we're still in the blueprint editor window, we can actually kind of see if things are working as they look like they should be. So if I hit play, you can see by this orange line that's following our execution line, you can see if, what you've done is correct, and if things are working, and if, the orange line isn't displaying where it should be, then, then you need to look back and see how you can fix it. But anyway, as expected, the event tick node is firing every frame, and, it's because it's not, I'll stumble my words there. Basically, because that's happening so quickly, we're getting this orange line here appear. It's moving along into set, which is setting a new value for our timer. Brilliant. Then it's moving along to check if the time has exceeded. Step 2, basically. Moving over to the branch section. And because these conditions are not true, the timer probably is, but these definitely aren't, because I'm not pressing anything on the keyboard. Branch isn't continuing on this orange line because it's, the value it's receiving is false, and we haven't told it to do anything with false, only true. So, straight away we can kind of see this is working already. And yeah, what we could do is press the buttons on your keyboard to, hold them down to see if this works. Then see if, the true line moves, and etc. You can keep testing to see if things work, which is quite nice. You don't really get that with normal scripting. You can visually test to see if things are linked up. But anyway, I'm going to stop that. Cool. So like I said, once you've done everything, compile, save, and it's time to test it. So let's close the blueprint editor and let's play our scene. Moment of truth. I mean, we're not hearing any footsteps yet, which is good because we don't want to be. We're not moving. But let's see what happens if I start moving. Oh. Oh. Sorry, I didn't mean to shoot the gun. Let's see what happens if I move. Hey, there we go. We're moving. Brilliant. Awesome. And we're hearing footsteps. And what you can also see is these red lines that are kind of following me. Now, if you'll remember, we set the line trace. I can't remember what we actually did to do it. I can't remember the option, what it's called. Basically told it to display in the game so we could see the lines. And yeah, as you can see, it's working. It's showing us the lines. So it's showing us where it's starting from, which is about midway point from the capsule, firing it straight down. And then you can, because there's that little thick red box at the bottom, that means it hits something, which is good. You can tell the raycast, linecast is working, essentially. And the reason why there's gaps in between is because those gaps are when the timer hadn't reached 0.2 seconds. So the branch, that first branch, wasn't set to true and therefore wasn't activating the line trace. So that's why there's little gaps in between. So let's keep walking along. What happens if I jump? Hopefully we shouldn't hear any footsteps. Good. Brilliant. And if I work back, you can see where I've jumped in the air. You can see the lines are now being fired from a slightly high position and going straight down. And because they're not touching anything, as we can tell by those thick red boxes, they're not telling our footstep sounds to play. Brilliant. And with that, we're all good to go. Way, we did it! Brilliant. So hopefully you understood that. Let me know if you had any issues with it or there's anything you're stuck on. Unreal can be very intimidating when you're first thrown into it. And I haven't really talked about the interface of Unreal itself at all yet. So hopefully, and maybe I will in the future, I just didn't have time in this video. But it can be very intimidating, but once you get the hang of visual coding and using blueprints, it's actually fairly easy to work with. You just need to know what your options are. You just need to know what all these nodes do and how they work with each other. So yeah, if you're struggling, I absolutely understand. Throw me a comment and I'll try my best to help you out. But thanks very much for watching. I hope you've enjoyed. If you did, please let me know what else you'd like to see from Unreal and Wwise, because I'm still deciding what I want to kind of talk about. I thought it was a good place to start, but I'd love to know what you'd like to learn about. And yeah, just any general suggestions I'd really appreciate. So I've been Henry Scott. Thank you very much for watching, and I'll see you in the next one.